Hello?
Yes. Can we start, or are there are there people we can wait for?
I think we can start.
Okay. Okay. Good. Good. So I know you have done a lot with Onditi in terms of the part of embedded programming or embedded systems. So mine today, I want first of all to introduce some basics regarding mobile programming. Then from there we can see how best we can utilize the remaining time. It's very short, but we can utilize it to get somewhere, at least get some basics on some of the platforms, because I know some of us have used programming environments before, even when you're doing your second year project. So for now, I think what we can do is to look at what we can do with mobile programming. So let me project my screen, and I'll be sharing the notes later. I should be having multiple screens so that let me split my screen. Just give me a minute so that I'm able to juggle between two screens. Sorry. We are going to look at mobile programming, and this will be a build up on what you may have covered, especially some basic programming on Android, and maybe for it to interact with the hardware. Uh, but for today, we look at the what you call the basics, and tomorrow we do some bit of programming. What I expect from you, um, I'll give you the programming tools that we may need to install. Some of us might have used those programming tools, like the Intel, what you call the JetBeans and the like. So, but let me first of all take you through some of those basics. Um, most of us are familiar with this development environments. Let me see by a show of hands how many have worked or have programmed with Node.js. Okay, I have quite some good numbers. So it's one of the most popular development environments that's actually supporting a lot of server end programming. React, mostly React JS. I don't know how many have done with React. Okay. Swift, Swift, Swift. Kyoko, you have worked with Swift. Who has worked with Swift? That is for what you call I've Apple none. Uh, in this class, none has done Angular. Angular, we have some. We have Sige. I think on the one. No, there are a few. Okay. Bootstrap. Bootstrap is of almost everybody. You should have interacted with Bootstrap somewhere. Kotlin, Kotlin. Craig, you have Kotlin, yeah? And Jaramba. Good. Um, Flutter. Flutter. Okay. That's good. I have a few representative of Flutter. Java. Java. Java, you have a few. Yeah, it's quite a good number. With Kotlin and Java, definitely you're home and dry. So if you have done Java, then chances are you have also done Kotlin, because Kotlin came to undo the mess that was started by some people like Oracle by taking over Java. So I want us to focus on Kotlin that mostly we use to develop Android applications. We'll also look at how we can use Flutter. So between today and tomorrow, I want you to install IDEs that support those tools. And one of the IDEs that I recommend you install is which one? Which one do you use for Kotlin? Well, said they have used Kotlin.
Android Studio.
Android Studio. Another one? Android Studios?
IntelliJ.
Yeah?
IntelliJ
IntelliJ. So IntelliJ, do you pay for the license of IntelliJ or you get it for free?
is a student version which is free.
Or there is a student version? Okay, fine. So which one do you recommend that is the fastest of the two? IntelliJ or Android Studio? Android Studio is entirely free, right?
Yes.
Yes.
Okay. So which one do we use? Both? What are the limitations of the student version?
For me, there is none, but you can use Android Studio.
Okay, let's use both of them so that we have some basic understanding of the two. So we'll be programming for Android. Swift, it seems most of us, even the timelines for understanding the Swift Objective-C environment is something else. But let's see, let's first of all start quick very quick with Kotlin, so that we can write a few lines of code. So because Android are very popular, let's see how we can use that. Okay. So with that, now we can proceed. And what I expect from you is that you will install those IDEs. Um, it's very easy. If, for example, if you install IntelliJ, it will install for you all the engines that are required to program with Kotlin, Java, and those associated Groovy and the like. So it's upon you to decide which IDE is more economical for you. Um, it's very important to note that programming for mobile has come of age. I don't want to take you into the world of history, but it's important to note that some basic phones a few years ago were supporting very few functionalities: SMS, calling, and maybe some music, ringtones. Today you can program for everything, from camera to anything that you think of this world, including some games. So the world is limited, and that's you are given opportunity by the mobile application environment to develop or to utilize the potential of this. So when what we'll be developing, maybe we can agree whether to develop fully fledged apps that run. For example, you have a whole hotel management system, or you can provide what you call some form of data sharing platform. We look at what kind of the kind of applications you can support, from games to what you call image processing applications, while us looking at the limitations of the platforms. I don't want to say why we should go mobile. You know, it is ubiquitous, because by 2023, about 8 billion or 9 billion people had their phones. We have also noted that the phone is on your hand, mostly 91%. So these statistics, they are not very important, but it's very important to say that the reason why mobile apps have become very popular is because, one, mobile phones have received a lot of subscription and usage, and two, it's a handy device that you can use every day. These statistics may not be very, of course, they are just statistics, but when you say that you look at your device approximately 150 times per day, compared to the number of times you go to a TV or a radio or even your computer, then you can say this is the device that you'd want to write application for. But before some years, let's say when I was doing my own programming, and when we are using what you call development tools and environments for, we used called J2ME, Java microaddition. Uh, During those times, we had so many kind of devices, what you called fragmented devices. There were devices from Samsung, they had their own Symbian operating system. We had Nokia with their Nokia operating system. We had Alcatel, and therefore there was a lot of what you call heterogeneity in the devices. And like in the desktop world, where we say that in case you have operating system, most of the people are either using Windows or using Mac, and the processor knows how to behave when it's running most of those applications. But for the devices, the processor power, the processor itself, they were not built from the same architecture. So it became very difficult for us to write applications that would run, one application that would run on most of those devices. But of late, we have seen a shift from device heterogeneity to platform heterogeneity, meaning that as much as we have now devices that can support everything, like the Android phones and what you call the smartphones, what do they call them smartphones? The problem is now the competition between various players, and it has now boiled down to iOS versus Android. Windows decide. I think Windows just happened to exit from the market for the phones, although they are still doing some what you call responsive Windows that can run on small devices. They assume that with Windows you can run it with even on tablets, but on native mobile phones it became very difficult for them. Symbian, which used to be Samsung, uh, was it some? No, it was Nokia, right?
Yeah.
Nokia, yeah, operating system was overtaken by events and overthrown by Android, and we have seen this competition of Android versus iOS versus Chrome and the likes, and Windows, which is not very popular on the mobile platform, has created a lot of heterogeneity. That's why most of us sometimes you find that if you walk move around, you see big billboards showing you that you can get access to their store or to whatever business they want by putting logo of Android and the logo of Symbian, not Symbian, but iOS, that is Apple. So nowadays we have boiled down to two technologies or two platforms, and therefore it makes sense when you are considering developing a mobile application, looking at what is highly supported by Windows, not Windows, mostly Android, and what is highly supported by iOS, and the market reach. Android has become very popular because of the market reach, and therefore, um, when we are developing the applications for mobiles, we need to look at a few things, and some of these few things are to do with. I think I'm using the old slides. Let me just see the slides that. Yeah, I uploaded the wrong slides. Sorry, but it's the same thing. So I hope. Uh, so this is a modified version of what I was presenting. So when you're looking at mobile factors, we see that when you want at the moment now when you're seated here, just like the way we do with the system analysis and design, when you want to develop what you call a mobile applications or mobile applications, there are a few things that you need to put into consideration. Number one is the human factor, the way we respond to mobile phones, to our mobile phones. Limited attention time. So in most cases, you'd want to make or to break your message within a very short span. What does that mean? For those who have done mobile, limited attention time span, 4 seconds. What does that imply? Like,
Yes. So is this um, is this talking about the user who is using the application?
yes.
Yeah. So see, 4 seconds is like a single point of concentration can be 4 seconds, and after 4 seconds it will shift to something else, maybe even away from the phone. That's how I understand it.
Yeah, because it's on your hand, you just want to stare on it and see whether there is a calendar invite, isn't it? Upcoming event. And that's why
Yes.
you find that most of the notification are brought on a banner, you know the banner, what you call the banner.
Yes.
Whatever, like a WhatsApp message has come, they do not expect you to read a whole one page of the message. So what they do is they give you what you call as a banner that should scroll up there, so that the moment you stay on your phone, you can see. Like now, I'm looking at my phone and I'm seeing that there's an upcoming event for this class, meaning that I couldn't miss this class because it pops up, and within 1 or 2 seconds, I'm able to know that I have a class with ideas. So the factors that we need to look at is when you're developing, it's not like in the desktop, people are sitting there reading everything. You need to take the what you call the advantage of the 2 seconds or 4 seconds the person will look at the phone. The other things that you need to look at when you're developing a mobile application is the context in terms of the mobile device itself, the change in position, what we call orientation. Well, sometimes when you're playing videos, it looks odd when you are watching that video on portrait mode, and that video is just occupying the center of the screen. If you take that video to a computer or a TV, it looks better because it scales to the size. So in that case, therefore, you must also look at how your application can 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 be context aware. We call it context aware. Can change with the context of the position, meaning that when you rotate your phone, it should be able to go landscape, and somebody will be able to see the menus are even better, more pronounced when it's on landscape than when it's the video scales up to fill the whole screen when you put the mobile phone on landscape than when it's on portrait. So the constant, what you call the mobile context, is very important. We call it context awareness. We can call it context awareness factors. That the orientation, the location awareness are very important. That your device can change and can give you information based on the context it gathers from the locality, given that it's a mobile device. The other thing is the capability. Not the mobile phones come with different capabilities, even if they are smartphones. There are those which comes with a lot of processing power, better battery life, and bigger screen. So people are preferring mobile phones with the end-to-end screens instead of the small screens that we used to have with the Murikamwizi and Akina Android, with the keyboard taking the rest of the space. So they decided to remove the keyboard so that the screen can maximize on the size of the phone, and instead, therefore, we use what you call the virtual keyboard or keypad. The other factors, what you call like the market rules, of course, it's very important to consider in Kenya what is expected, in US what is expected. You find that people get tired of some products very fast, and therefore you may find that the market game may change from time to time, and the product life cycle, they happen to exit the market very fast. And this is what pushed Windows out of the mobile market, because they never opened up their kernel such that people, the way the Android did, to open everything and people can develop their app. I don't know how Apple survives, but they have been able to survive even after closing their kernel. Their model of what you call giving what you call platform for development is a bit strict, but they have been able to survive the market. Yes, somebody says cult. Maybe you can explain. Yes,
Okay.
this is Edwin. Edwin says something about cult.
Okay. For my case, I guess for Apple,
Yeah.
uh, as much as they are offering better processing powers and other amenities on the phone,
Mm.
in the aspect of them being rigid in terms of their iOS, they don't
Mm.
allow a lot of developers to have an easy time to develop an app for Apple.
Yeah.
But now there's a business model whereby the Apple product is over glorified.
Mm.
It is seen as a state or a symbol of class. So as much
Yeah.
as they're selling the electronic and the processing speeds and the better performance,
Yeah.
they're also selling the idea of status. So people buy it just as a sense of status. So that's why I'm calling it some sort of a cult.
Yeah, yeah, yeah. I agree with you because almost everybody, when you move out of that zone of just using a phone, you feel like owning an Apple device is the best thing in this world. Just like in the motor vehicle industry, where somebody says, when you know own up a Mercedes Benz, you're at the top of the world. The fact is, like, there are better vehicles maybe than Mercedes, but you don't see them, right? It's more of a cult. I agree with you. I have an Apple phone, but for me, I don't see anything big about it because I just bought it because I found other people buying. Uh, I happened to visit. I happened to visit China, and everybody in China was buying iPhone. So, and then with my small machine that I had called Nokia, was told, why do you should need to have Nokia when Apple here almost for half the price of Samsung in Kenya? So you just get it. So it's more of a cult because you find that even the application they sell everything that you want from them. They sell. So why should I be buying every app I need, whereas Android provides everything for free? Anyway, that cult has served them in the upper markets, especially in the US, China, and Europe, because you find that those guys use the phone as a status device than just what you call something to do this. And that's why they also their process of approving the apps that goes to the app store is also very rigorous. It's not easy to publish your application on App Store the way you'd publish it on Android, what you call Google Play. In terms of business models, when you are developing, and it's very good that Edwin, you have mentioned about the card. It's very important that as much as you we glorify um, Apple, iOS, and the likes applications. People in Kenya have come to also start behaving like the Western African on the and what you call the European and the Chinese, that they have come of age. They are no longer associating themselves with the small phones. They just want these big named phones and big named cars. Akina, what you call Bugatti are here in Kenya. Akina, we thought akina, did you call them uh, Kanyan and BMW, and those are no longer a threat to anybody because they are just common cars. When you're developing an application, look at the business model. Like when you go out there, you'll find that majority of the people would want to run the application on Android, but they still have a few clients who still glorify and iOS, and therefore you have also to bring about what you call app for for people, a few of them who are using iOS, and another one for the majority. Just like the way we say that there is the Equity Bank, and at the side of the Equity Bank, there is what they call the prime bank, which people enter when the doors are just open. Somebody has to open for you the door to enter because they just want to take a selected few. But the two of them have their own market game, and that's why you have to consider even those few who'd want to enter the door, and the door gets closed. So there is also importance of trying to look at different interaction possibility, or what you call user experience. By the way, let me tell you, Ed, the reason why Apple devices are over glorified is that if you try to use the interaction possibilities, what you call user experience, they have the highest user experience. I tell you, I've used this one, and I can tell you, although it is over glorified, I cannot go back to Android for sure, because the user experience is so good from what you call voice interaction with the Siri, from the way it doesn't hang at any other time, the security features in this phone, the user experience, I tell you, is so good, and the protection against some incoming applications that are meant to steal your data by penetrating through the kernel. Anyway, I'm not glorifying it, but I'm saying it is the user experience is one of the things why people have not gone wrong in refusing to use the device, as expensive as it is in terms of owning up the hardware and also installing the application that are always bought. In terms of the screen, every player now has capitalized on the use of the screen. The screen has become so interactive such that you no longer need keyboard and mouse to operate your mobile phone. You can do everything with the multi-touch and the multi-gestures, including the visual. Uh, right now, most of us are paying or we're using our transaction by just looking at it with visual recognition. And therefore, the haptics within the application, the camera, all this, you can create an application that capitalizes on all these features, from haptic to camera to accelerometer to tilt and GPS, and you come up with a fully what you call context-aware application that takes care of detection of and recognition of everything. And it would be such a wonderful thing that somebody will not know that they are using just the power of a camera, including the health sensors. You can interact, you can interface your mobile phones with these what you call wearable sensors and get the power of healing and treating and taking care of patients on the move. But it's very important also, as you do that, remember there are a few issues in terms of responsiveness. You need to make sure that your mobile phone is as responsive as possible, including calls. An application should not block your calls because you are using it. It will be so wrong, because the primary purpose of a mobile device most of the time is voice calls. And when the voice comes, it should be able to counter what you are doing without interrupting or dropping it. So it gives you an opportunity. And if you are seeing most of the current phones, the calling button comes just up there, leaving you all the other space so that you know there is an incoming call, but it doesn't interfere with the application. Some mobile phones before used to drop whatever else you are doing because they were not multitasking. But now with the multi-core processors, you can do much with your phone. The call comes, you respond to the call, and you continue with what you are doing. But this also goes together with security and limited RAM or storage within the device. But majority of the computers, not computers, but mobile phones and mobile devices are coming with the high-end cores, not single core, but multi-core. Or what you call, it's no longer quad core. I think we have gone beyond quad. What is the highest now? What is the highest number of cores that we can get on a mobile phone? 1 megapixel of camera is nothing now. We are now talking of mega, and almost those that are bypassing those of commercial cameras. So how many cores do you have currently? Just check the latest phone, the latest Samsung, or the latest what do you call it, iOS 15 or iPhone 15. How many cores? Maybe you can investigate during your free time so that you know. Most of these mobile phones are now coming up with a lot of resources, more cores than those that are found on our desktop computers. There is an overlap here, but it's important to note when you are doing the operating, what you are developing for the iOS. We may be developing for the iOS. Let me uncover this, but yeah, it doesn't make a lot of sense. So um, you look at Swift. Swift is the latest development platform or framework for Android, not Android, but iOS. But we'll be looking at the kits you can use to create your application. The core OS kernel and drivers are already hidden, but you can look at the core frameworks. Maybe by tomorrow, we can look at the basics of Swift so that we compare the basics of Swift and the basics of Kotlin and see the both of them, how we can do the 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 application development for both, because we'll be looking at the both environments. If you look at the app development for Android, of course, it has several stacked layers. You can see from up there, the browser, the home, and everything, with what you call the lower kernel being Linux. All of us knows that Android runs on a Linux kernel, and therefore um, iOS is a completely different model, because if you go back, you find that whatever is at the core here, the kernel here is what you call iOS kernel and the drivers, and then you're given the core foundation framework that you can use to develop your application. So there are several stacks here for iOS. Then we have what you call application development framework. You can use packaging, all these, and the most other thing you can use is Android runtime environments and libraries that are always available for free, including OpenGL and what you call media framework and SSL for security. Just the same libraries, some of them which are available in for use for Linux. Most of us are programmed for Linux. So as long as an app only uses the application framework, Google claims that the app will work on future, and therefore, well, what we are looking at, because it's an open architecture, then it's recommended that you understand how Android framework works. Windows used to be there. I'm not saying that it's not there, but it has already it failed the market penetration, unlike Android and and iOS. But of course, they have this framework which you can use. Your app UI and logic, you can define your own, and then you can use this framework HTML5 and JavaScript. We used to have what you call Windows Phone, and people try to write application for those and then upload them to App Store, Microsoft App Store, using things like what you call ASP.NET. Do we still have people developing for mobile? No, for Windows Phone.
No.
No, so this framework is no longer useful. So as much as you have the foundational uh, kernel that that is closed by Microsoft, uh, they never exposed it. But unlike iOS, which has survived the closed kernel, what you call jailbird kind of approach, where they do not expose to you their fundamental architecture, then they have created frameworks that allow people to develop applications without interacting with the kernel. But the problem with the Windows, I don't know whether it was marketing or anything, but they never penetrated. So I'll not go deeper into some of these things, because we can already we are familiar with them, like the responsiveness. Most of us knows why we are using Bootstrap. It's because you want our applications to be highly responsive on the screen size, on the orientation, and many other, including battery consumption. your application should not be a battery guzzler, because somebody would want to retain that power for a whole day or 2 days. So when your application is not in use, then it should allow the battery or the computer to go into sleep mode as soon as it's done. So I think I've already mentioned this, but it's important to note that Apple iOS is mostly was being developed using what we called in, application called not application but framework, call it Objective C, which is a variation of a variant of C and C++. And today it has been simplified by using what we call the Swift framework, but we'll see how to do that. Android mostly relies on C and C++, but most of the application Android Studio really wanted us to use Java, but because of the problem of Java being now part of Oracle, Mike, Google decided to come up with their own and kind of promote Kotlin as an alternative to Java, because Kotlin, Kotlin. There are those who have said they have used Kotlin. Tell me why you use Kotlin as an alternative to Java.
It has shorter syntax, and then there's a framework called Jetpack Compose
Mm,
that comes together with Kotlin that really eases the Android development. It's more declarative.
mm,
It's more declarative. I
okay.
mean, like you just say
Mm,
what you want to do, not how to do it. Like if you want a column,
yeah,
like the Jetpack Compose library
yeah.
says, like it has a function called a column. You use something called composables. So like it's intuitive, yeah,
It
in some
it,
way.
it doesn't require you to write those classes the way Java was really making you do so many part of codes. So this allows you to use what to develop an application on the fly, right? So
Yeah.
it's a quick way. The other advantage of using Kotlin, yes, it has null safety. What do you mean by null safety?
You can make it. You see, in other languages like Java and C, when you try access memory that has a null pointer,
Mm,
legal access of memory, it will throw an
mm,
exception.
mm,
So Kotlin introduced nullable values where you can have a default value to return
mm.
in case you're accessing a null value,
Okay.
so your app doesn't crash.
Yeah, great. Yeah. So instead of and the good thing about Kotlin is that instead of what we call throwing exceptions at runtime, it is statically done in a way that the null pointer is never an issue the way it used to be with Java. We used to experience a lot of null pointers problems when at runtime, and it's so embarrassing, especially if your application is at production level and you see something throwing a null pointer. And this null pointer is because if you're accessing, for example, a device or a drive, and the environment changes a little bit, Java doesn't know, therefore it has no reference to that, and it used to throw, or it throws what you call null exception. The good thing is that Java Kotlin does what you call checking on the nullness and what you call compile time, and tries as much as possible as I think is it Hansel has said to give it some default, right? Windows is entirely written in C and C++. There are also some what you call some toolkits that you can use to develop, but I am not so keen on Windows because it's no longer part of the market. Um, The other things that you have to look at, and they are not, I don't have to really emphasize on it, is when the mobile is stolen. All of us may have been victims of losing a mobile, or mobile gotten stolen, or you sending your personal information, sharing it to the wrong number. So it's very important looking at when you're developing, you have to look at possibilities of enhancing user experience, so that they take care of um, all your um, security mechanism, from personal data to the device itself. I don't want to go into through this table, but you can see the what we call the level of security that are implemented by most of these, especially when you compare Google Android and Apple iOS. You can see access control. Uh, Apple is always at the top. Isolation and encryption, of course, you can see um, the security there. So you can tell why most of the people would be so comfortable, maybe using, especially for very sensitive data, uh, people using iOS at, for sensitivity. If you go to the US embassy, they use purely they use Apple devices, not because it's not because it comes from US. It's because of the security and permission level that are required for you to crack data. Even when you take it to the DCI forensic, it takes time, and they may not be even they are not be able to crack what you call an iOS phone or an iOS device the way they would do with the Android. So that tells you why people who take data seriously go for the iOS. Uses hardware encryption on all data. So it's the kind of level of encryption that is applied by iOS is super and high. And all apps in App Store are verified by Apple. So you cannot just upload or push an app to App Store. There is an rigorous process. That's why you find that we do not have as many serious, what you call free apps available for iOS, because um, it has to do a lot of verification from Apple. Permissions also required for SMS, making calls, GPS. You cannot just install an application and start entering into your SMS or into your voice contacts and GPS. So at some point, iOS can refuse to take some of those apps that expose your location, especially using GPS. So for Android, it's permission for everything during install. There is no app verification, which allows some malware to exist in the App Store, or in what you call in the Google Play. I don't know whether today Google has put up verification process for those who publish Android applications. Anybody who has published an Android application of late? Yeah. Who verifies them for Android? Mm, mm, okay. Okay. So at least for now, they try, because there are some apps that used to be uploaded, and they would ask you for all the permissions. But little did you know that they are even stealing your what you call personal data and pushing it somewhere else. And that's why US were so keen on developers for mobile manufacturers like Huawei, would sneak in some what you call some low-end for apps to scavenge on the data of all the phone users within the networks they are supporting. So, whereas there was a market problem, or what you call market rivalry, there is also what you call the sincerity of both the markets spying on each other. I don't want to talk about Windows because it's no longer there. I don't want to talk about limited RAM because we are aware of why limited RAM in some older OI Windows, Linux, not Linux, but iOS and most of this. So then it comes to Android development. I think mobile application development, there are several platforms, but most of them have gone extinct. Like Symbian was very popular a few years ago when we used to even to have Nokia Lab. We used to use Symbian to program for most of those applications. But now the dominance is on Android and Apple, with Windows struggling to retain their grip. But they have perfected their game on the desktops, but not on mobile. So I think what we'll do, because we'll only be developing for Android and Swift, I want us to look at the platform we have mentioned. This table here is too much for you to read, but I'll post this so that you can read it during your free time. We need to look at once we install. We have agreed, like we are going to install something like we say. Did we say IntelliJ and what you call Android Studio? Yeah. So um, for example, just a minute. I see this. Not- So those who have programmed can tell me this environment with this. Which environment is this? Which ID is this?
IntelliJ.
Yeah, IntelliJ. So what you want to do, and the part that I'm demonstrating, is that I want you to uh, install the either IntelliJ, maybe it can be student version or even the trial version, as long as you have you can install it and use it now. Just start testing it with the hello world, just basic, before we go into now details, because as long as you have written your application and it creates a whole project package similar to the way it does Java does. So it's not any different from Java. This one of mine is just saying hello world and doing some loop for and printing uh, 10 in a range of 1 to 10. It prints that. It's just very simple. And once you install your IntelliJ, and then you install what you call the development environment, what you call we call it what? Java development environment, Java JDK. This one by default it supports open source, so it will install for you the runtime environment, including virtual machine. Then once you run, we can now try to do a very basic mobile app using this. So by tomorrow, we should be able to have this environment. Then we can do a very small, because of time limitation, very small mobile app. And then over the weekend, maybe we can give ourselves some chance to play around with with Swift if it works. So what I wanted to show is like once we install that, similar to the way I have here. So once you install your development environment, what you call IDE, similar to the this is just a dummy screen. We need now to have what we call a few other things like the emulator. So we need to invoke the emulator, Google Android emulator, IFE. So some of this may be old, but we can look at those emulators that you need. So you can look at any latest of the emulators that you can use to test your device. So depending, you can choose several emulators, or you can just invoke the standard ones, as long as they give you the feel and look of the current mobile. So like this one that is here, it's more like the older mobile phones that used to be there, which looks more like a tablet. And nowadays we are looking at mobile phones that can also be folded, so it would be good for you to see. We would want to write just a very simple application that can render something. So if you can be able to demonstrate that using an emulator, that will be good. I don't want to see anything to do with the Windows, because we are not doing any Windows. iOS, we want also to see how we can use the iOS. If you can be able to write something, you may not be able to publish, but if you can use some emulators to do the iOS and learn some basic of Objective-C, which is a superset of C and what you call Smalltalk, then we should be able to write. We are not going to write anything for Symbian and Band, because they are not important for us now. So let's look at how we can use several emulators also for iOS to demonstrate that we can do something small on Swift. So publishing our apps, maybe we may not, but if we can get those, like one of us has said, we can try to, once you create your application, you can see how best you can push it to the App Store. But of course, as we have mentioned, there is rigorous certification requirements and approval process that might delay, and therefore we cannot rely on that. So publishing may not be very, very practical for now, but if there are those who can demonstrate that they can take it end to end from development to publishing, then be it. So we have currently we have 3 active app stores. Okay, not for, I think for active app store. Which one and which one and which one? For purely for mobile. Yes, the first one. Halisi.
iOS.
iOS is not an app store.
App Store.
App store. That's Alexa App Store. The other one?
Play Store.
Play?
Play Store.
Play Store for
Google Android.
Google Android. And the third one? Yes.
Samsung Store.
Hiyo ni gani? That one I've not heard.
Specifically for
Android
Samsung.
has a lot of stores. Android has a lot of stores.
Android have, other than Play Store. Yeah? But
Yeah.
but we are looking at the competing three.
Huawei.
Huawei,
App
they
Gallery.
call themselves what?
Gallery.
App Gallery. App Gallery. They're struggling, but I hope they have. Yeah. Yes. Galis Edward.
Uh,
Yes, Edward.
I was just, we have these mobile devices because I'm sure when you're talking about mobile devices and mobile computers, we're not
Yeah.
just looking at phones like iPhones, Samsung.
Yeah.
We are specifically looking at mobile devices that are running some sort of application or some sort of system. Now,
Yeah.
we have these devices that are by, let's say, the enforcement agencies like the Kenya Police. Let's
Yes.
say in a police station, let's say in Nairobi, in town, there's a tower, maybe at
Uh-huh.
the
You're getting lost. Huh?
police station
Is it
that is
my network or
broadcasting all over
eh,
Nairobi area. Then we
Edwin?
have like
Edwin, you
each
got
officer
lost
has, and
somewhere.
they're like, hello,
You got lost somewhere. You are not very clear. You can repeat again. Is Edwin there or he has disappeared?
Yeah, perhaps he just types in the chat. It's easier.
Mm, mm. Okay. So anyway, the developing a mobile application is not as different as what you do with the other applications. And what I think Edwin is trying to say or ask is we are not looking at only mobile devices that are the screen size is less than 600 megapixels. But what I wanted to say is that as much as we would want to say that most of the devices, including laptops, are mobile. A laptop is a mobile device, but it can take anything else. It can take anything that can be done by a desktop, and actually, it can take the power of a server. So I'm not looking at mobile programming in terms of mobility. I'm looking at mobile programming in terms of resource constraints. I don't know whether that is clear. Mobility is one thing. Even the police that use walkie-talkie, they use it for mobility purposes because they would want to monitor the field and communicate when they are on the move. Those are mobile devices. And they have their own very important, like what you call the walkie-talkie are very important. But we are not kind of saying that we want to develop application for everything. We are looking at certain just like the way we do with the REST API. REST API has what you call constraints, 6 constraints that we look at. One of the constraints that you have mentioned that is very important is mobility. So once it qualifies on mobility, that's a mobile device, right? The second one is the resources and the portability. It's mobile, but how portable is it? Can you put it in the pocket, or you need to uh, put it in a knapsack or something like that? So I'm looking at not necessarily that we are developing for even Murikamwizi. We are looking at how we can use what we call a standard smartphone that's running on Android or running on iOS and write some applications that can be shipped for use. So um, everything can be mobile, but the mobility can be limited to what power that can be. So look at also resource constraints in terms of processor power, the memory capacity, and all these are some of the constraints that are defining what we need with mobile programming. And therefore, with the mobile programming, you need first of all to design your application, you need to know the phones or the devices that you want to support. If you want to support up to tablet level, then that's okay. There are some applications you can develop that are multi-platform. That means that you develop one application, especially with the HTML5, and it can scale up and scale down to fit in any device from desktop to the smallest phone. In that case, then we are not talking of only mobile programming, but cross-platform programming. So you have to design and look at the market data on why you need that particular. Then once you design or stroke develop, you have to do what you call, you can do the what you call incremental way, or what you call the any other methodology that we used for prototyping to push that application to the market for development. We call it a continuous integration, continuous deployment. So you can build and deploy your prototype. So, but I think because it's who was asking the question? Edwin. Is Edwin back?
Yes, I'm back. Had some issue with the network.
Okay. Yeah. Okay. So you wanted to say something?
Oh yes. So I was asking. I heard that recently, some 2 years ago, Huawei had partnered with BCI. They were giving them mobile devices and integrating some technology that would assist in surveillance. So I was just
Yes.
inquiring, when we are focusing on mobile computing, it is an aspect of coming up with an application that is just will be running on those devices, or we are focusing on coming up with application that can collaborate with other mobile devices.
You see, in developing applications, there are two approaches. We can use what you call the native. The native, when you talk of native, it means we are developing an application that purely runs, for example, on Android, or purely runs on iOS. And this application cannot, an iOS application cannot run on Android, and vice versa. Meaning that when you do native programming, it means that you're capitalizing on all the powers, all the features, and everything provided by that particular platform. But there is the other way when we say that, for example, when you use HTML5 and CSS3, it's possible for you to write an application and convert it, write what you call, you create your pages, and you convert them into an application like the ones we download from App Store. But most of those have been created using a framework that gives you very nice CSS, very nice look and feel, which almost close to what you can build as a desktop application. In that case, therefore, we are saying those applications are not just mobile, but they are responsive. They can run on multi-platform. They can be mobile. They can run on a mobile platform. They can run on a desktop platform. They can be run even using projectors. So it will depend. When you talk of mobile programming, in most cases, we are not looking at the cross-platform programming using HTML5 or those frameworks that are more responsive. You are looking at the native programming, where we say that we want to write an application that takes fully advantage of Android, or takes fully advantage of Linux. Not Linux, but iOS. But it's not that it requires a browser to run, because some of these requires just the browser to run. It doesn't matter whether some of these applications, then you have to install them, and they have to see that you are installing it on Android, and it cannot, such an application cannot be installed on iOS on because of what you call the features and the incompatible technological either hardware or software platform, what you call dissimilarities. I don't know whether that answers your question.
Yes, sir, very well.
Yeah. So I think what we need to look at also is how we can develop a mobile application with an idea team. I know you guys have already done what we call innovation, what we call design thinking, what we call innovation studies, and you need to start with ideation or ideating, and then from there you look at whether you see, based on what Audrey was saying, is that whether you want to develop it as a native application. If you want it as a native application, it means that you must make everybody have a native phone, like like an Android phone or an iOS. You can decide it to be an internal web platform, such that that platform can run it as what you call as a closed platform. Then once you initiate the review, they review and see what are the advantages of taking a mobile application compared to an HTML web. So they can make a decision, and that decision will guide on the mobile what you call application project that you can initiate. You can start making what you call an Android based, or two, an Android and an iOS, or one application that is web and can run on any device in this world, as long as it is light enough, it is responsive enough. Then once you develop and test, then you can prepare for release, and your product will be up there in the market. So I don't want to go into details about review or to call design, but it's very important to know that you have to review the technologies that are available. Then in terms of what you call the other technical requirements, you can brainstorm in a group. When it comes to sorry. So when it comes to development and testing, you have to look at the best development tools. We have already looked at them, and we have agreed to use IntelliJ and Android Studio to start doing our development and testing of the application. And I think that sounds. The design, it can be high-end design, or what we call low fidelity or high fidelity design. It will depend on what level of design you want. Then in terms of deployment, it's possible to look at the releases, the product release cycles, and publishing. So I think most of these other things, I don't want to go into details about them, because they have to do with just development and deployment and how you can use. Okay, so try as much as possible to adhere to what we call mobile programming practice. This may not be the only ones, but it's very important to avoid using cookies for any mobile application. You need also to use appropriate client storage technologies for local data to avoid it getting lost, or jamming your mobile phone or the client mobile phones with unnecessary data. Only very necessary data should be used. Try as much as possible to look at the data size so that it doesn't overstay. So it's also important to look at a few other things, like perceived latency, especially when it comes to storage and processing. Make telephone numbers quick to call. This is a feature that you guys have also seen, in terms of if you have a text message on your message, a phone number on your text message, you find that it is put in a way that the moment they discover this is a telephone number, it's put in a way that you touch it, it starts calling, and can even look up into your what we call list of members that are being called. So we'll be looking at how to also deploy our applications. For now, it's more of mobile, but Edwin mentioned about mobility as a key thing that has made us also go cloud. And you'll find that most of our phones are ready to interact with the cloud. Actually, they are cloud computing compliant, because you can seamlessly, like when you found that when I started this call, I started with my phone, and then when I opened up the desktop for sharing the screen, it automatically switches from my app, my Google Meet app on the phone, to the Google Meet app on the laptop, without dropping what you call um, embarrassing drop. It just tells me switch from here to here. And it's very hard for somebody to tell that you are used the two devices. They'll not see the what you call the gap on how you exit and come back again on a different device. So look at how we can therefore integrate mobile apps, the existing cloud infrastructure, and other items. So need also to look at various mobile ecosystem, from social media to wallet to apps to anything that you'd want to do with mobile phones. So having said that, therefore, what I expect you to do, and I've mentioned this, is tomorrow we are going to have a quick demo of an Android application. Who will do it for us? Those who have done the Android? Very quick one. You don't have time to. We want just something apart from Hello World, something that can demonstrate that you can use the emulator, or you can run it on your phone and show that I was able to create a very basic application, maybe like, can we say a passport application, or can ID application? Who can do it for us by tomorrow? Okay, let's talk of hotel or room booking, what you call university hostels, room booking. Just a basic interface for a form that you can use to book for a room. Who can do it for us? There's so many guys who say they're okay with Kotlin. Yeah, great. Thanks. Is it Joel? Thanks, Joel. Joel, it'd be great. We really appreciate. So just come package, very simple. You demo to us from code to, because we don't. I'm trying to save because I know much of the time was taken by the other part of the hardware. It'd be good for us to understand some basics. So Joe will help us to understand how to do the Kotlin. Yep. Somebody is raising up the hand.
Excuse me, sir. The projects were supposed to do Kotlin only, or we can do Kotlin or Java
Kotlin and?
or Java.
If you have no problem with Java, you're okay with Java?
Yeah.
Native Java? Yeah,
Yes.
you can do it. Will you want to demonstrate to us tomorrow?
I was saying the semester projects.
No, the semester project. There is nowhere they say any language, but if you're comfortable with Java, you can do it with Java, right?
Okay.
Yeah. As long as you don't use what we are calling frameworks that generate for you things very fast.
Okay.
Yeah. Be coolly, 100.
And what is the timeline for this semester project? Because the way things are looking, it's a very small
Yeah.
time frame between now and exam time.
Which project?
See, the one mentioned by the other guy.
See, is it the semester project you're talking about? I don't manage the project, so I don't know.
So is there an Android development
No, no, no,
project?
no. These ones are just to help you. I'm just equipping you with the knowledge for you to consume out there.
Okay.
Yeah,
Okay.
I'm not forcing you to do, because I know I'm coming also a bit late. Yeah.
Yeah.
So we are doing this one for our own internal consumption. So
Yeah. Yeah.
yeah. So anybody who would help to do a Swift one? Swift. Objective C. Did not have anybody, but maybe there are those guys who are daring and they can do a quick and dirty thing for us. Who'd want to dare the iOS? Aringo, you can do that.
No, I think for that you need to have a MacBook.
Uh, you cannot use an emulators,
Uh,
or
and,
for development you must have a MacBook.
the last time I checked, you have to have a MacBook,
Yeah,
unless it's changed. I don't know.
those are the tricky things. I don't know what we can do, but let's see if nobody has something like those tools, including the hardware to do the Swift. We can just do some basics from online. See whether we can. Let's first of all deal with the Android, then we see whether we have any way to do Swift without necessarily having the MacBook. But if a MacBook is required, those are some of the limitations that make developing for iOS what you call a rigorous process. Good. It's 10:50, no, 12:50. We are past the time, but I think I really wanted to finish this bit so that we are only left with practice. Between now and Friday, not Friday, next week, I think only next week is remaining. We can just do quick and dirty programming without having so much of lecture. I'll share the notes with you, including some maybe tutorials that you may need. I don't know, whoever is doing Android, maybe you can share with us some materials. Those who are doing, all of us are doing Android, but it depends on whether you're using Kotlin or Java. Maybe you can share with us some basic code if you have, so that others can start testing it, trying on their own. Sasa, any question? So we can close there today. We meet tomorrow at 9. Yes, Gregory.